This problem says a Molniya orbit is a highly eccentric orbit of a communication satellite so here's the eccentric. You can see that it's a very flattened orbit, elongated orbit. So to provide continuous communication coverage for Scandinavian countries and adjacent Russia. The orbit is positioned so that these countries have the satellite in view for an extended period of time. So those countries would see the satellite for all this time. Okay, and then it will go out of view for this time. So that these countries have satellite in view for extended periods. If a satellite in such an orbit has an apogee at 40,000 kilometers as measured from the center of the Earth. So there's the apogee, and this distance is 40,000 kilometers. And has a velocity of 3 kilometers per second. So if it was going around like this, the velocity at this point is 3 kilometers per second. What would be its velocity at perigee measured at 200 kilometers altitude? So this is 200 kilometers, and we want to find the velocity there. Okay, so velocity at apogee, which is equal to 3 kilometers per second. And velocity at perigee is what we want to know. All right, now in satellite motion, what is conserved is angular momentum. Okay. And at apogee and perigee, the angular momentum is given by mass, the distance and velocity at apogee equal to mass, distance at perigee, and velocity at perigee. Now these distances are from the center of the Earth. Okay, so this distance is given to be 40,000 kilometers from the center, but this distance is given from the surface. So we'll have to, so this has to be from, we have to calculate that from the center. So the perigee distance is 200 kilometers plus the radius of the Earth and that is equal to 6,400 kilometers. Okay, so this is 6,600 kilometers. So we have to be careful of that. Okay. The mass cancels, so velocity at perigee is radius of apogee, radius at perigee times that. Okay. So, and we'll keep everything in so this is 40,000 kilometers, and this is 6,600 kilometers times 3 kilometers per second, and this works out to so it's going at 18.2 kilometers per second. Okay. All right, that finishes this problem.